To our webinar today. And today we will be discussing the topic installation and commissioning of the Fronius Tauro. So last week we looked at the introduction to the Fronius Tauro series of commercial inverters, and we shared quite a bit of details on the new commercial inverter from Fronius. And today we want to share with you more details, but this now looking at the installation and commissioning of the Tauro inverters. Joining me today for this webinar will be my colleagues, Mohammed Sidat, our Technical Sales Advisor based in Southern Africa, as well as Cyprian Okolo, our Technical Sales Advisor based in West Africa, Nigeria, and myself, David Mwangi, TSA for Eastern Africa based in Nairobi, Kenya. And today we will be presenting this topic to you on the installation and commissioning of the Fronius Tauro. Our agenda for today, we are going to be looking at a few topics, and we will look at, first of all, an overview, just to give you an overview of the Fronius Tauro inverters, plus the other commercial inverters already existing in Fronius. Just for the benefit of those who did not manage to join us last week. After that, we are going to look at the commercial system designs, choice of inverter, possible layouts, design tools. And after that, I'll be handing over to my colleague, Mohammed, who will be discussing the Tauro installation as well as the interaction between the Tauro and microgrids. And after that, Cyprian will be taking over for Tauro commissioning, service, and components exchange. And before we end, we will give you further information on all our other products. So to get started, let's look at the Fronius commercial inverters, the range of inverters that are available from Fronius as far as commercial installations are concerned. As you know, most of you know already that we have been having the Fronius Echo and the Fronius Simo inverters. And these are available in the power classes 10 to 27 kilowatts. So the Tauro, the Fronius Echo available from 25 to 27 kilowatts. And the Simo available from 10 to 20 kilowatts. Of course, these are three-phase inverters. Now, in addition to that, we are very excited about the new series of the commercial inverters. That is the Fronius Tauro and the Fronius Tauro Echo. The Fronius Tauro will be available in the 50 kilowatt power range, and the Echo Tauro will be available in the 50 to 100 kilowatt power classes. The Tauro, of course, has a bit of a difference with the Tauro Echo in terms of the number of MPPTs. The Tauro will have multiple MPPTs, up to 3 MPPTs, whereas the Tauro Echo will have only 1 MPPT embedded. In terms of the MPP voltage, also you can see just a bit of a difference between the Tauro, the Fronius Tauro 50 kilowatt, which will be having an operational voltage for MPP from 400 to 870 volts, whereas the Tauro Echo will have the voltage in the range of 580 to 930 volts DC. Let's now look at the commercial systems design. As we know already, when you are designing a commercial system or any other, let's say, solar installation for that matter, CapEx or the capital expenditure, and this includes the cost of inverters, the solar modules, and other balance of system components, are what are the, let's say, classical approach for looking at what should be chosen as components for systems. However, also OPEX is also an equally important cost aspect to consider, especially for commercial systems. And this is where now the Tauro gives us and our installers and also end customers a huge advantage over other commercial inverters available in the market. Because when you look at the CapEx and the OPEX of your systems, then this gives us the total cost of ownership. So therefore, choosing the right inverter, as well as an inverter that allows you a lot of design flexibility, has a huge impact on your CapEx as well as OPEX. And the Fronius Tauro is going to give us this benefit of design flexibility. and therefore guaranteeing our installers, all those people interested in designing PV systems around the Fronius Tauro, the lowest total cost of ownership for the same inverter power classes available in the market. When you're planning your commercial systems, the classical approach normally is to look at the choice of the inverter. And this, we are talking about what is the cost of the inverter per watt. And then we also consider the choice of the inverter power class. Also, something that is important is to look at the additional cost components or cost-effective components that can be coupled to such a criteria, as well as what is the distance from the PV generator to the transformer. So that affects, of course, the design around DC and AC cabling and the components in between. So this is the classic approach, but with the Tauro, we want to approach it from the different direction. We want to say, what is the distance of the PV generator to the transformer or the point of interaction or the feed-in point? That becomes one of the biggest advantages that the Tauro is going to offer you, as you're going to see later as we progress. And then all these other points then will be considered based on what is your design around the distances involved. Is it a rooftop system? Is it a field system? And therefore, what is the configuration around DC and AC cabling and how these are connected to the inverter? So going further into that, we can now discuss the choice of topology. And when you're talking about topology, we are talking about how the inverter is connected to your PV system. So we have two, let's say, ways that we can use the Fronius Tauro. And one is a centralized topology, and the other one is a decentralized topology. So when you're talking about these two variations, we have schematics that can help us understand what we are talking about exactly. As far as the central design is concerned, we can see that on a field of about 150 by 200 meters, we have an array here that has been installed. And counting our inverters here, we have about 4 inverters, and therefore we can assume that these are probably 400 kilowatts of AC power and an equivalent amount of DC power for the PV array. So as we can see with a centralized design, all the inverters are centrally located near the same location. And all the strings are collected and combined using DC combiner boxes. And these are coming to the inverter with bigger or thicker DC cables as far as the cross-section is concerned. And then from the inverters, then we are going with the much shorter distances of AC cabling from the inverter to the point of interaction or the feed-in point. On the contrast, we have a decentralized installation whereby we have the inverters collecting the string cables directly into the inverter, and then the AC cabling is running a much longer distance to the feed-in point. With the Tauro inverter, as you're going also to see much later, we can see that these are 8 Tauro inverters. And we can see that there is a constellation or a combination of 2 inverters that are connected as far as the AC cabling is concerned. And this is what we referred to as last week as the AC daisy chaining that will be possible with the Tauro inverters. So when you're doing a decentralized system, the AC daisy chaining configuration will allow you to save a lot of AC cabling, and therefore that will have a huge impact on saving on the AC cabling. And also, this is a highlight of the Tauro inverter that is going to affect, like I've said before, the balance of system components and therefore the capex of the system overall. So we can see that in this case, the DC cables are much shorter than the AC cables, and therefore in this kind of topology, we are referring to it as a decentralized topology. However, to give you better idea and to contrast the two, we can see below here we have 2 schematics. With a centralized topology, we have a DC combiner box here, collecting all the strings, and you're going into the inverter with thicker DC cables. On the contrast, we have the decentral design, whereby your inverter is placed just next to the PV array, and therefore the strings are collected directly into the inverter. But from the inverter, you are going out into your distribution panel for AC power with a much longer distance of AC cable. And therefore, the special attributes of the central design or topology is all the inverters are collected or centrally placed near each other. And this makes it easier for on-site transportation compared to a decentralized design. And also access to the inverters is much easier because you can access all the inverters from the same point. This therefore means that, as I've mentioned, all the module strings are collected through a DC combiner box and then connected to the inverter with bigger or larger cross-section DC cables. The decentral design has the following characteristics: that the inverters are distributed across the PV plant. The modules are directly connected into the inverter, and in this case, when you're doing a decentral design, this is also something to note, that you're not going to require additional DC combiner boxes, as all the strings will be connected into the inverter directly. Therefore, a decentral design has one cost-saving element, that the DC combiner boxes will not be required, but with a central design, DC combiner boxes will be, in most cases, be required. So as I've mentioned, the Tauro will give us a lot of flexibility as far as design is concerned. And one of these flexibilities is the design on the DC side. When it comes to ordering the Tauro inverter, you are going to order from Fronius either a pre-combined version, and this is the version that is going to do centralized topologies, and or a direct version or a D version, which is going to be used to do decentralized topologies. So how to distinguish the two is the fact that if you look at the back of the inverter, for a pre-combined version, it therefore means that all your strings are pre-combined before they're coming into the inverter. You have an area for DC power connection that has about 6 cable GLANDS where these cables can go through. And then inside the inverter, you have the DC V clamps where you connect your DC plus and minus for coming from your string array. And then for the direct version where you're connecting the strings directly into the inverter, then MC4 plugs are provided in the inverter, and all you need for your installation is the connection of compatible MC4 plugs into those provided in the inverter. In this case, when you connect or use a direct version of the Tauro inverter, then it means that string fuses will be required, but the additional advantage that you're going to get is that string level monitoring will be possible. And therefore, this is also another advantage of the decentralized or the direct version of the Tauro inverter. Let's now look at the choice of the inverter. So when you're planning with the Fronius Tauro, this is how you would approach the design of your system or planning of your system. So the first step is to understand the system challenges, and this means the local challenges. Are you going to do a non-roof system, or are you going to do a free field system? Then after that, you look at the system costs. What are the energy losses? And energy losses is something that is very, very important when you're designing your system, because this overall has a huge effect on the return on investment of your system. Any amount of energy generated that you cannot be able to utilize to power your loads, that is like money you are losing in your system. So the Tauro has quite a number of advantages, and we can look at all these in a different webinar, whereby you can minimize the energy losses that you can experience over a period of, let's say, 10 years, 15 years, or 20 years, and comparatively look at what that means compared to similar inverters available in the market. Also, something else that you would need to understand as far as system challenges are concerned is the ease of servicing your products or the inverters. So the Tauro has a very unique service concept, and this will be addressed much later, and you're going to see how easy it is to service the Tauro series of inverters. Then once you understand your system challenges, it's time to look at to decide between different design options. Are you going to go for a centralized or a decentralized design? What is the most cost-effective layout that you want to use? And this most cost-effective layout must also address the loss optimization. You want to minimize your system losses as much as possible. And this therefore leads us to the choice of the optimum solution. And the choice of the optimum solution will therefore also depend on, is it a ground-mounted system? Is it a roof-mounted system? Will I go for centralized or decentralized, or will I go for a combination of centralized and decentralized topologies? And the Tauro, because of the design flexibility that it's giving us, is going to allow us to have an optimum layout, which we are going to look at. So let's look at these layouts that are possible with the Tauro inverters. As I've mentioned before, we can talk about a D all P option. The D standing for the direct option, and the P standing for a pre-combined option of the Tauro series of inverters. So with the D option, this is the decentralized design or the decentralized topology. As I had mentioned before, all the strings are collected directly into the inverter, and then from the inverter, you do daisy chaining depending on the size of your installation. And then from a 200 kilowatt block, that means either 2 by 100 kilowatt Tauros or 4 by 50 kilowatt Tauros, you can achieve daisy chaining. And then from that block of 200 kilowatts AC, you can go with a much bigger cable to the transformer or the feeding point. So the special attributes of this D option of the Tauro will be as follows, as far as the inverter is concerned. That the inverter will have, of course, as I mentioned before, MC4 plug sockets that are provided, and therefore from the PV array, the strings, you'll come with appropriate MC4 plugs for plus and minus, and you're going to connect them into those provided in the Tauro inverter. For the Tauro Eco 50 kilowatts, we have up to 14 strings that can be connected. And with the 100 kilowatt, we have up to 22 strings that can be connected using MC4 plugs. And with the Tauro 50 kilowatt, we have also approximately 14 strings that can be connected. And when you look at the entire inverter, how to visually identify which inverter you are dealing with. Is it a pre-combined or a direct version? In this particular photograph, we have a Tauro Eco 50 3D. So this is a 50 kilowatt three-phase direct version. And when you look at it visually, you can be able to identify the inverter. So on the surface, you're going to see two DC disconnector switches, which are on the front panel of the inverter. When you come to the bottom side of the inverter, you will count a total of 14 MC4 plugs. And these are where you are now connecting your DC strings from the PV array. Also, the AC area has about 10 AC cable GLANDS provided. You basically know that this is an inverter that can achieve AC daisy chaining. So because you come with your AC input from the bottom, for instance, and then to the next inverter, you're going to go with the next set of three-phase cables. So you can see here we have phase 1, 2, and 3, and then live and neutral and earth cables going into the next inverter. So what are the attributes, or what are the special characteristics of the direct topology or the direct Tauro inverter? Mentioned before, all the inverters are near the modules, long AC cables, no additional components such as DC combiner boxes are required. What is the cost advantage of a direct version or topology? The cost reduction on the DC combiners is that is a guarantee. That is a saving already. You can count on the Tauro for that. And then the performance, because of the higher AC cable cross sections that are possible with the V clamps, then you can go for much longer distances with minimal power losses. And this is now how the Tauro is affecting the total power losses in your system. The V clamps that are provided on the AC side can accommodate cable sizes of up to 240 millimeters square, and that also has a huge impact on your design flexibility as far as the distances that you can cover are concerned. Also, a further advantage is that because of the MC4 plugs directly provided, the ease of installation with a direct version of the Tauro is obvious, that there will be quicker installation with a direct version of the Tauro. Let's now look at the central topology, or what we call the P version. And in this case, we are looking at an installation that is done on a rooftop. So all the inverters will be placed near each other in a central position. Then it means in this particular case, we are covering an average from the farthest strings of about 110 meters to where the inverters are positioned. And this is possible because the Tauro inverters can handle 95 millimeter square on the DC side strings. And therefore, it means that this would not be a problem running such long distances of cables on the DC side. And therefore, that would mean, because you are running much longer distances, as I mentioned before, that you would require to incorporate DC combiner boxes from where now you come with much bigger cables into your inverter. From the inverter, then you go to your transformer, and in this case, AC-DC chaining might not be possible, and therefore each inverter is directly connected to the point of interaction, or probably you might want to use AC combiner boxes depending on the exact design that you're going for. Similarly, looking at a free field installation with a centralized topology, a similar approach is there, that all the strings are collected, and then from the string with a DC combiner box, you're coming into the inverter. So how do you recognize a pre-combined version of the Tauro inverter? So this is, for instance, a 100 kilowatt inverter pre-combined. On the front panel, you can see 3 DC disconnector switches, and we have also the pre-combined DC connection area that is clearly labeled with engravings for plus and minus. So it will not be, should not be that you are going to make any areas with the reverse of polarity here. So it's clearly labeled for DC1 and DC2. You can see where you are going to connect your appropriate DC cables. Then on the AC side, you can see that we have only 5 cable GLANDs provided. And this means, therefore, that this inverter will not be capable of AC daisy chaining, as already explained before. So let's now look at further explanations into a rooftop installation. Because when you have a rooftop design, you are able to increase your self-sufficiency by making the most efficient use of the available roof space, and therefore higher PV power can be installed. In this particular installation, we are looking at an east-west orientation possible. And what can happen as a design consideration is you say that all my strings or arrays that are oriented east are going to be collected through DC combiner boxes and are going to be fed into one inverter. And then all the arrays that are facing west are going to be collected and fed into another separate inverter. And we are going to look at why this might be the case for some installations. In another installation, a variation of a decentral system, we can also talk about bringing your DC cables directly to the inverter. And then from the inverter, you go into the feeding point with much larger or thicker AC cables. So, but what are the design rules for east-west orientation? Some things or hints we can give you as follows. When you're using the Fronius Tauro, you are able to connect all your different oriented strings onto one MPPT. And this therefore means that you can have a more cost-effective inverter using only one MPPT, and also over-dimensioning is possible. So similar to all our other existing inverters, you can over-dimension the DC power for the Tauro, and therefore be able to mitigate any shedding or power losses due to dust cover and things like that, or changes in irradiation. So in this case, when you have modules that have different orientations, but the angles are not too steep, then the mismatching errors or losses are minimal and can be neglected. However, we do recommend that the number and type of modules must be identical in all strings. You must ensure that for this kind of orientation, where you have different orientations and are connected to the same inverter, then no shading is there, and all the modules within the same string must have the same inclination. So please, when you're doing your designs for commercial installations, kindly take note of these recommendations. Also, for shaded systems and steep inclination angles, we recommend that you use smaller inverters, and then you're able to split your PV generator so that the DC power that is coming to the inverter and consequently the amount of AC power available across the entire system is much more uniformly distributed. Let's now look at the design tools that are possible for the Tauro series of inverters. As you already know, we do have our free design tool that we call the Fronius Solar Configurator. And this is designed for basic designing that allows you to do different configurations on the strings possible. However, for bigger or for yield calculation, irradiation simulation, and stuff like that, we do recommend to go for third-party tools that such as PVSol or PVSys or other tools that you may be using that are good enough. However, we just like to caution that you should not rely only on the third-party tools. Also, make use of the Fronius Solar Configurator, because if you rely only on the third-party tools, you might be omitting or you might overlook some possible options that could be there as far as design considerations on your string lengths are concerned. And the reason for this is because different programs will be using different inverter data for calculation. So this is something that we also encourage you to do, that regardless of the system design tool that you're using, also always make a point of using or referring to our Fronius Solar Configurator to confirm that you have designed the appropriate cable or string length for the particular inverter, because things like irradiation, temperature, and so on are very well factored in the Fronius Solar Configurator. So that brings me to the end of my part of the presentation. But before I hand over to my colleague, I would like to launch one poll, and I would encourage you to share with us your feedback on this particular poll. So the question is, what is your preferred topology for mounting systems? Is it a centralized design? Is it a decentralized design? Or are you not sure about this? So kindly give us your feedback. Will be much appreciated. It will give us also an idea how well you are going to be making use of the Tauro different variations. So I'll leave it on for the next 20 seconds or so, and then I'll close it and share the results with you. So thank you so much for all of you who have managed to give us your feedback on that. So maybe just about 10 more seconds, then I close it. So, all right, so let me close it, then I'll share the results. So you can see that a good number of our attendees today are quite used to doing decentralized designs. So that means that you are connecting your string cables directly to the inverters. Another 23% of the attendees today are doing centralized designs, and 14% are not sure. So this will, like I said, be a factor of your design, and we are also very happy to discuss with you the exact configuration that will be ideal for your installation. So I'll now be handing over to my colleague, Mohammed, to continue with the rest of the presentation. Mohammed?
Thank you, David, for your very good part of the presentation. So yes, as my colleague David did explain on how to design a Fronius Tauro in the most efficient way possible, I'll now be moving on to the next section, which is installation of the Tauro itself. Before I get onto that, what's so special about the Tauro? It's very important to understand the different sections of the Tauro before we have a look at how to install the AC and the DC connections to the Tauro. Basically, what I have indicated on the screen on the right is a screenshot of the Tauro. And if you look on the left of the inverter, this is where you will find all our power stacks, as well as our booster modules. Okay. So for example, with the 100 kilowatt Tauro, you will get 2 power stacks, whereas with the 50 kilowatt Tauro, you will get 1 power stack. Some of you might ask, what is a power stack? The power stack is basically a combination of PC boards that take care of the conversion of DC to AC, as well as filtering of your DC and AC signal. Okay, then moving on to the central part of the inverter. This is now where we will find the DC fuse area. Okay, so if you are going to purchase the direct connection Tauro, you will get all the fuses incorporated inside the Tauro. Okay, if you go for the pre-combined option, this will be classified as the DC area. You'll also find the pilot, which will be the communication card inside this area. And you'll also find your DC breakers, which are these little turning plugs on the top. Then if you look at the top of the inverter, this is where we find our AC and DC filtering circuits. This is also where we find the DIN rail, okay? And this is where the SPDs will be installed on the DIN rail. On the right of the inverter, this is the AC input area, okay? So this is now where all your AC connections are done. And this is also where, for example, you have the option to order the Tauro with an integrated AC breaker. Okay, so what's really good with the Tauro is that we've really segmented the inverter quite well. So, I mean, you've got an AC side, which is clear on the right. You've got the DC side in the center. And then you've got your power boards on the left and the top of the inverter. This is also very important when you move on to installation, because you will see with the different installation types that you can go for. It's very important to take note that the majority of the weight of the inverter is concentrated on the top left of the inverter. That's very important. Okay. So with the Tauro, we again extremely robust. We have an extremely easy installation compared to our competitors, which I will show you about just now. We also have great design flexibility, which my colleague David spoke about. Again, with this, it leads to extremely good BOS cost reductions. And my colleague Cyprian will then run you through the easy and fast maintenance, if something does go wrong with the Tauro. And my colleague Cyprian will also take you through the system monitoring hardware on the Tauro. So it's very important to install a Fronius inverter in the correct site. Okay, so with the Tauro, it is rated as IP65. Okay, some of you might be asking, what does IP65 mean? Okay, so it means integrated protection, and the 6 stands for dust tight. So this means that no ingress of dust can get inside into the Tauro as long as the Tauro is closed correctly or sealed correctly. Okay, the 5 then stands for is basically protected against water jets from any angle. Okay, so what that means in a nutshell is that you can install this Tauro outdoors. Okay, and it will still operate even when it's raining directly on the Tauro itself. Okay, obviously this does not mean you can install the Tauro underwater. That's not possible. But what is possible, as I said earlier on, is installing it outdoors. Okay, so any of these first 3 combinations are perfectly fine. What's really good on the Tauro is that we can basically install it in direct sunlight. Okay, and this is due to the double wall active cooling design that we have incorporated. With the Tauro, you can install it anywhere from 0 to 4,000 meters in terms of altitude. Okay, however, above 4,000 meters, it is not suggested that you do install it because you can get a lot of derating above 4,000 meters above sea level. Okay, and the reason why altitude has an effect on PV inverters, well, the first reason would be the higher you go, insulation gets further reduced. Okay, also the higher you are, you also have a reduced cooling effect on the panels. And as you all do know, if the temperature of your panels rise, the DC output automatically decreases as well. And all of this will then lead to reduced AC power. Again, please don't install the inverter in a highly toxic environment, such as a factory where maybe there's a lot of ammonia in the air. And the reason for this is the Fronius inverter has an active cooling system where it actively draws in air from the environment and passes it over the power electronics. So if you're passing in ammonia into the inverter, it could lead to degradation of your power electronics. Again, don't install a Tauro in a bedroom, but again, I don't think this would even be happening, okay, due to it being a commercial inverter. Don't install it in a barnyard where maybe there's animals that could chew on the cables. Don't install it in a highly static environment, because as you know, ESD is very bad for power electronics, and our Tauro again is not immune from that. And then please don't install a Tauro in a greenhouse. The reason for this is that the ambient temperatures could rise easily above 50 degrees Celsius. With the Tauro, we have done extensive tests as well. Okay, so the various tests that we have done in order to ensure that it is IP65 is that we've carried out, for example, freezing tests, where we've taken this inverter, put it into our testing room, and frozen it to its absolute limits, of which is about minus 25 degrees or minus 40 degrees Celsius. Okay, and it was still able to operate. What we've also done is we've also tested it according to its water endurance, okay, or for that IP rating. So for example, we've pretty much sprayed the Tauro Eco directly with a water jet, as you can see in the bottom, and the Tauro was still able to function without it tripping or anything to that effect. We've also taken the Tauro and we have done quite a few mechanical strength tests, okay. And if you look on this picture on the right, as you can see, we have a whole lot of cables connected in. So we basically connected every DC string onto the Tauro. We've connected the AC cabling, and this is what we call the endurance test, electrical endurance test. And this will basically ensure that even if we put the maximum current per string, the inverter is still able to function properly without anything tripping or without anything, starting to smoke or anything to that effect. It's very important to install the Tauro in the correct position. The reason for this, as I said earlier on, is because the weight of the Tauro is sort of mainly in the top left section, okay? And this is because that is where the power stack is found, and also where your filter boards, for example, are found. And this will pretty much explain each orientation that is allowed and each orientation that is not allowed. Okay, another reason for the allowed orientations versus the disallowed is the topic of active cooling. Okay, so with the Tauro, we've got a fan that pulls in air from the slot over there, and then it passes out hot air from the sides of the inverter. Okay, and as you also know, hot air rises as well. Okay, so all these combinations are allowed. None of these combinations are allowed. For example, let's have a look at the first one that isn't allowed. If you look at this setup over here, your weight is centered over here, and you've got a slant which sort of provides greater force due to gravity. Okay, and this could lead to a situation where your Tauro could just simply fall off a wall. Okay, and if anybody has experienced a grid-tied inverter falling off a wall, you do know if you drop an inverter from 2 or 3 meters, your PC boards will start to shatter, and it could lead to a very costly repair. Okay, so please make sure you do take adequate attention to what's allowed and what's not allowed. With the Tauro, we also do ship it. No, we don't ship it, but we do provide the option. So you can order these, what we call handles, as an additional extra to the Tauro. You could use it for various things. Well, the first thing you could do with these handles is that you could use it to lift the Tauro, okay, in order to mount it. Okay, the second use for these handles is that you could use it to mount the Tauro on the floor. Okay, so what's very important with the Tauro is that you cannot directly mount it on the floor. If it is going to be a horizontal mount on the floor, you need to provide it with these little mounting brackets. And the Tauro will basically then sit on top of these mounting brackets, and this is what we call permissible. Okay, with the handles, it's very good if you're an EPC to always, have a bunch of these lying around, especially if you're going to be installing a lot of Fronius Tauro inverters. The reason for this, as I said earlier on, is that you do need to use these handles in order to make it much more easier for you to mount this inverter onto its backplate. Okay, moving on to the installation site. If you are going to install more than one Tauro inverter, or even if you're installing one Tauro inverter, please make sure that you do take adequate attention to these details. So what you do need is you need a minimum distance of 50 centimeters between the top of the Tauro and the ceiling. You also need a minimum distance of 50 centimeters between the side of the Tauro and the wall. Okay. You also need a distance of 50 centimeters between each Tauro inverter. Okay. The reason for this side distance is because of hot air is going to be passed out from the sides of the inverter. So obviously it needs enough, space to, escape. In terms of the permitted humidity that the Tauro is allowed to be installed at, you can install it in any humidity levels of between 0 to 100%. So you can install this inverter at the coast perfectly fine, nothing's going to rust. So you will not have any issues on that. Also, in terms of the ambient temperature, it is allowed to install the Tauro from an ambient temperature of minus 40 degrees Celsius up to 65 degrees Celsius. Okay, so this Tauro can be installed in the Kalahari Desert and you will get extremely good performance values. Okay, if you are going to order the Tauro with the AC disconnect, please make sure that the minimum temperature will change from minus 40 degrees Celsius to minus 25 degrees Celsius. Again, please take careful attention to the maximum DC, open circuit DC allowed per string, and that is 1000 volts DC. Moving on to the transport and mounting. Okay, so the inverter itself will be delivered in a cardboard pellet. Okay. A maximum of 3 inverters can be transported on one pellet, okay, due to the sizing of the inverter itself. In terms of the delivery contents, so basically what comes in the box, the inverter will come in the box, your wall mounting bracket, so that's a back plate of the inverter will come in the box, and also the quick start guide will come in the box. So the Tauro is a heavy inverter. If you're looking at the 50 kilowatt Tauro, it's 74 kilograms, and the 100 kilowatt Tauro is 103 kilograms. So again, we suggest that you use at least 3 people to lift this inverter. Also, what's really cool with the inverter is that you can use a crane to lift it. Okay, so maybe, I don't know, you need to lift the inverter to the top of the ceiling. What is provided on the Tauro is that we do provide you with eyelets. So you can see it here on the left and on the right. Having a look at the mounting bracket, please remember the mounting bracket will come as standard with the Tauro. Okay, so it will come delivered in the box. And with the mounting bracket, you need to use the mounting bracket in order to mount your Tauro. Okay, it's compulsory. There's no way of getting around it or choosing not to use it. So with the back brackets, if you are going to mount it to a wall, okay, you can see you've got your screws there on the top, okay, and also your 3 screws there at the bottom. And if you look at the picture on the right, you can actually see how the Tauro itself clips onto the back plates. Okay, so you can have a look at that little hinge, and that basically clips onto the back plates, and the bottom of the Tauro is then secured, okay, with these 2 screws over there. If you do choose to mount your Tauro horizontally, you will need to purchase the handles, okay, which is not included as standard with the Tauro. It is an additional extra, okay, but this will then enable you to mount your Tauro flat on the ground. And when you do this, the Tauro itself comes with these slots that these mounting brackets will go into, and from that you can then mount it on the floor. Remember, these mounting brackets can also be used to lift the inverter. As you can see, we have slots for hands, and this will just allow you to also mount your inverter much easier if you are going to mount your inverter vertically. So I'm playing a little video. On this video, you should see the installation of the Tauro in a quick 30-second nutshell. But as you can see, we've got the back plate with 6 screws. As you can see, my colleague here is putting up the back plates. And then once you've got that secured, you basically then just lift up the Tauro. You don't have to use the mounting handles. You can just lift it up, click it into place, and then please make sure you then secure those 2 screws at the bottom. Having a look at the dimensions of the Tauro itself. So from point to point, so from the one end to the other end, it's about 1.1 meters. And the actual height of the Tauro, if you're going to include the eyelets, it's about 755 millimeters. But if you're not going to include the eyelets, it's about 644 millimeters. If you're having a look at the mounting brackets, the mounting bracket is sort of inclined at a 3-degree angle. Okay, there's a very good reason for this. And the reasoning for this is to allow for easy drainage of water. Okay, and also if you live in an area where there's a lot of snow, it also allows the snow to melt and then escape safely without interfering with the inverter itself. The width of the Tauro will be around 0.3 meters, 0.35 meters. Once you have your Tauro mounted, the next important step will then be to open up the Tauro in order to do your AC and DC connections. Okay, so what you need to do is we suggest that you do use a Torx screwdriver. Okay, so a Torx 25 screwdriver, you need to remove the outer screws. Once you've done that, you then open up the bonnet of the inverter. Let's call it that. The reason I'm calling it that is because it's very similar to how the bonnet of a car works. When you open up the bonnet of a car, you need to secure it somehow. And with the Tauro, the securing is done via a lever. So please make sure that you do click that lever into place. Okay, and this will prevent the shell of the Tauro falling on you when you are doing connections. With the Tauro installation on the AC side, we have different types of cabling or cores, as my colleague David also spoke about earlier on. The first option you can order with this inverter is a multi-core. So if you have a multi-core Fronius Tauro, this is how the AC will look at the bottom of the inverter. The multi-core cable gland will allow a diameter of 16 millimeters up to 61.4 millimeters. And we'll also have the earth cable, okay, connection, which is that point over there. And this will be from 10 millimeters diameter to 25 millimeters. If you, however, choose to go for the single core Tauro, please note with the single core Tauro, we have 5 glands, and each gland can take diameters of 10 millimeters up to 28 millimeters. Then if you're going to go for the AC chain option, okay, so in this case, you're going to have your in and your out. You're going to have your earth, live, neutral. So earth, live, neutral, and then L1, L1, L2, L3, live and neutral. But anyways, with that, you get a diameter per slot of 10 millimeters to 25 millimeters. Having a look at the AC connection, our AC connection is done through V-clamps, okay? And what's really cool about the V-clamps is that they kind of secure the AC cabling really tight. So even if somebody comes and tries to lug on the cable from the outside, it's very difficult to pull the AC cable out. Okay, and this is the reason why we choose to go for the V-clamps. Okay, so with the V-clamps, you can kind of set it up in 2 positions. If you set it up in the first position, you can take a cross section of 185 to 240 millimeters squared. But if you take this little middle piece over here and if you swap it over, so if you rotate it completely over, it can then allow you to go for smaller diameters, so for 35 to 150 millimeters squared. And you can actually see the hole is quite secure. Okay, so this really pushes down and puts some pressure on the cable, and again, just makes it a much safer installation. Your cable lug, again, is only needed for grounding. For your AC connection, you have to choose the specific choice of cables. Again, attention, use only the following cable types for connection with V-clamps. That's very important. The first one is an RE, solid round conductor. This is what a solid round conductor looks like. The second one is an SE, solid sector conductors. Again, this is what a solid sector conductor looks like. The third one is the RM, round stranded conductors. That's an example of round stranded conductors. Then you have SM, sector stranded conductors. Okay, so please make sure that you do use one of these 4 AC cables with the V-clamps. Okay, so again, this is a real-life image of the solid versus stranded cable types. For your AC connection, your choice of the cable is very important in terms of which tower you're going for. For example, if you're looking at the Tauro Eco 50, in terms of your AC cable options, you get the option for standard, either as a single core or multi-core. That's your cable dimension. You also get your AC disconnector. That's your cable dimensioning. And then for the daisy chain option, that's going to be your cable dimension. Okay, so let's say if you choose to go for the Tauro Eco with the AC disconnector, please make sure that you look at that cable dimensioning for your AC cabling. Okay, however, if you choose to go for the daisy chain option, please make sure that you refer to that value. Okay, in this case, it so happens to be the same. With the Tauro Eco, with the 100 kilowatt three-phase, if you do choose to go for the stranded option, please make sure you look at the cable dimension, as well as for the AC disconnector and daisy chain option. For your DC connection, we have two possibilities, as my colleague David said earlier on. You get the direct and the pre-combined. With the direct, your string fuses are integrated. Okay, the number of strings for the Tauro Eco 50 kilowatt will be 14 strings. For the Tauro Eco 100 kilowatt will be 22 strings, and for the Tauro 50 kilowatt it will be 14 strings. So for your DC connections, what I do have an example over here is for the Eco 50 kilowatts with the direct version. You can see your DC cabling directly goes from your panels, your strings directly to the DC inputs on the inverter itself. So there's your positives and there's your negatives. And then having a look at the pre-combined, the cable connection will be from 25 millimeters squared up to 95 millimeters squared. M32 cable gland from 10 millimeter diameter up to 25 millimeter diameter. With the pre-combined option, you will have to go for the integrated V clamps. Okay, so this will be on the DC side. And for example, with the Tauro Eco 50 kilowatt and 100 kilowatts, because they only have one tracker, we have two positive connections and two negative connections on the V clamps. Okay, so this is an example of that over there. So your two positives and your two negatives. However, if you are going to go for the Tauro 50 kilowatts, the Tauro with three trackers, you will have three positive and three negative connections for the pre-combined option. For your DC connection with the direct version, okay, so D stands for direct. MC4 plugs come as standard, and they can take cable area of 2.5 to 10 millimeters squared. If you are going to have about 10 amps per string, please make sure that you make use of a 15 amp solar fuse. However, if you are going to be using 12 amps per string, please make sure that you order the Eco with the 20 amp solar fuse option. Okay, again, the reasoning for this is always suggested that your fuse should be 1.5 multiplied by the short circuit current per string. Then having a look at the pre-combined option, okay, the pre-combined option will come standard with DC V clamps, okay, and these DC V clamps can take an area of 25 to 95 millimeters squared. For your data communication, in terms of your wiring, please make sure that you do follow these specified guidelines. So if you are going to, for example, add an Ethernet cable, only pop out a section that you are using. Okay, so don't pop out each section, only pop out a section that you're using. The reason for this is in order for the inverter to maintain its IP65 rating. Now moving on to the microgrid applications with the Fronius Tauro. I won't go into too much detail on this, but just to add it in a nutshell, the Fronius Tauro will be compatible with inverter chargers, and this will now allow you to take your Fronius Tauro and take it off-grid or take it into a microgrid hybrid solution. Okay, so the Tauro is extremely flexible. It can be used in grid-tied systems, hybrid systems, or even off-grid systems. The latter two can be done if you are going to use an inverter charger such as Victron. The reason for this is that the Tauro will come standard with MG50 or MG60 country setup. The Tauro will also be compatible with PV-GENSET solutions. The reason for this is due to the MG50 and MG60 country setups. So again, if you're having these very big 1 megawatt, 2 megawatt installations, off-grid type installations where there's a generator on site and they want to add solar, to cut down the cost of diesel, this is also possible. So the solar will be active if there is any grid available, okay, and if the grid does go down and the genset comes up, the solar will also be active in order to decrease the amount of diesel that you're using. But if you do want further information on the PV-GENSET solutions, I have added these two links. We will share this presentation with you, so you will also get these two links as well. From Fronius, we do provide our own PV-GENSET solution. The only really additional thing that you do need is this PV controller from Fronius, okay, as well as an ATS, which should already be present on site, especially if the site already incorporates a diesel genset as well as the grid. Okay, I'm not going to go into too much detail due to time constraints, but again, we will be running webinars discussing the solution in the future, and we've already done it in the past as well. We can also use it with other third-party PV controllers such as DIVE, Elum, etc. And this is for the more advanced solutions where you have more than one genset on site. Okay, I will now do one poll before I hand over to my colleague Cyprian. I really appreciate if everyone could share their input to this poll. The question is, where do you usually install commercial inverters for plants greater than 100 kilowatts? Do you install it in an inverter room? Okay. Do you pole mount it under PV panels? Do you install it on the roof? Or do you wall mount it outdoors? I'd really appreciate your response. And I will close the line in about 10 or 15 seconds. Okay, I'm going to be closing the line. Okay, I'd like to share the results with you. As you can see, the majority of the audience goes for the inverter room approach as well as the wall mount outdoors approach. Okay, just remember with the Tauro, you can do any one of these possibilities. They're all possible. Okay, which is really good to hear. Okay, Cyprian.
Yes, so let's continue from here. I will be handling the Tauro commissioning. Yes, big thanks to Dave and Mo who have handled the design and installation respectively. So we shall be continuing from this slide onwards with the commissioning. And as we might have known, the Tauro doesn't come with a display, just as is the case with the Gen 24, as we discussed in our previous webinar. So it means that we will be commissioning it with a monitoring or commissioning device, as you would put it, and then of course with a communication gateway. And this communication gateway is what we call the pilot, as in the case of the Gen 24. And then how best to do this, rather than starting with our new commissioning app, which is called the SOLAR.START app that was launched a couple of months ago. Yes, so with this, you can have your Wi-Fi access point open by tapping the touch-sensitive button on the inverter once. Once you do that, the Wi-Fi access point will be opened, and then you can now start the app and of course establish connection to the inverter and then set up your device and network respectively. So from the screenshots, as you can see, once you click on the start installation button, the app automatically starts to search for the open access point. And then this is of course made possible once you tap on the touch sensitive button. Your Wi-Fi access point will be open, and then you can now have access to the installation or commissioning wizard, as we can see on the screen. So that's one step of how you can achieve that. You can also do this via a browser using wireless LAN connection, or as you preferably call Wi-Fi. Open, but this time around you have to use a browser. So first off, you need to open your Wi-Fi access point by pressing the button on the inverter once. And immediately you do that, you go to your Wi-Fi settings. You will definitely see the device ID stating Fronius Pilot with the serial number. And then once you select it, you will have to enter a password. And the password, as always been the case, is 1 straight up to 8. That is 1, 2, 3, 4, 5, 6, 7, and 8. So once that is done, you can now go to the address bar of your browser. We recommend the Chrome browser, and then you now enter the IP address 192.168.250.181. So once this is done, it will of course automatically link you up with the installation wizard, and then you can now continue with the next or the rest steps of the installation, which is the product setup and of course the solar web setup. Then another way you can do this is via using LAN or the Ethernet port or connection procedure. With this, you'd have to establish, of course, connection to the inverter. But in this case, you can use your network cable. We recommend a minimum of Cat5 cable. So Cat5 and above would do. And we also recommend that you use the LAN 1 interface port on the pilot, as indicated or shown here in this illustration. So once that is done, you don't need any password. So all you need to do is to enter the IP address 169.254.0.180 into the address bar of your browser. And like I said earlier, I would prefer or recommend the Chrome browser. And then once that is done, you would have access to the installation wizard, and then you can now continue with the rest of the commissioning, which is pretty straightforward. So it's basically 3 steps, 3 easy steps for commissioning. The first is the network setup. Next is the product setup, and then the solar web. Network setup basically is you connecting the inverter to the network. And then product setup is basically imputing the settings and the parameters and specifications of the system and the inverter as well. And then solar web setup is when you now bring your entire system onto our database, which is the solar web, for easy and remote monitoring. Good. So let's talk about access authorization. There are basically 3 access authorization levels. So we have the guest, we have the customer, and then we have the technician. So for the guests, basically you only have access to the basic information about the system. So it's more or less like a read-only access of the authorization. No login is necessary in this case. It is not possible to set up the inverter or network connection. Only dashboard view is possible. All other menus are encrypted. Then we have the customer access authorization. In this case, the password will be entered during the network setup. This is necessary for accessing the network, of course. And then you cannot make any entry to critical settings like power grid settings. So as you can see here, we don't see the padlock symbol on the device configuration, energy management system, and communication. But then you don't have access to the power grid settings. Good. And then the technician access authorization level. In this case, the password will be entered during the product setup, and it is necessary for accessing the product setup wizard. Of course, you would have access to all inverter settings except the grid code settings. And if there is any need for you as a trained personnel to gain access to this code, you would have to request it from our tech support. They will send you an assent form, and then once you assent to it and sign, they will definitely send you the access code for the grid code settings, and then you can now make the necessary settings you wish to make. So that's it for access authorization. So like I said earlier, in order to gain access to the Wi-Fi access point, you would have to press the touch sensitive button as indicated here just once, and then you would have opened or activated the Wi-Fi access point. Then, if you press it twice or tap it twice, you would be activating the WPS function. WPS function is the Wi-Fi protected setup. Yes. So this basically comes in very, very handy when you're using a router. So in this case, you wouldn't need to go through the process of password authorization and access grant. And it makes it quite easy to connect with a router once you have your WPS function enabled. And then holding it down for 3 to 6 seconds enables you to confirm service messages. And of course, you can also activate or deactivate the key lock with this process. So the key lock basically is this same touch sensitive button. In the case where you are afraid that it might be inadvertently operated unintentionally, and you don't want this to happen, you can press it or hold it down for 3 to 6 seconds, then you will now deactivate it. So in the case where you want to reactivate it, you would have to do the same thing, holding it down for 3 to 6 seconds, and then you would have reactivated the key lock. Good. So in the case of LED status, we have color codes indicated by the respective LEDs, that is the communication and operation LED. So this color code gives us indications of the inverter status. So for example, in this case, we have the communication LED on yellow and then the operation LED on green. So looking at the color code, we can track it and see that for green, yellow, that is operation and communication respectively, it simply means that the inverter is running and then but the network not yet configured. So for this example, we can simply say, for example, that the inverter is on, that is the DC and the AC cables are all connected, the inverter is powered, it is running, but then it is being commissioned. It is in the process of being commissioned. So you have it indicating yellow, meaning that it is not yet configured. So this can simply pass for this explanation. So, but just in case if you have any of these other LEDs, you of course have this to help you explain what they all mean. Good. And then when you now finally have access to the dashboard, you will be able to access your profile with this headshot. Clicking on the headshot gives you access to your profile where you can change the language, and then of course have access to your messages if there are, and then change user. So let's take, for example, you're an installer or a technician using the technician access level, and then you finish installation and wouldn't want the customer to have access to sensitive grid settings. You could as well change the user here and then maybe replace it with the customer access level. So here you can actually change the user. And then clicking on the menu button gives you access to the device configuration and other settings such as energy management, system settings, communication, safety, and grid regulations. Yes, so in terms of state code, as in the case of the Gen 24, as we explained in previous webinars, the state code this time around comes in 4 digits, contrary to what usually happens with our snappies, that is the snap inverters. They're usually 3-digit codes, and they come in different error classes or different state code classes. But in this case, it doesn't follow that, process. What you get is a 4-digit number, and then it comes in ascending order. So let's say you have a state code of 1, 2, 3, 4, for example. If you now get another state code, it will come in as 1, 2, 3, 5. So it comes in ascending order. And then, of course, it's always displayed on the dashboard of your monitoring device. And then if you need further information, you can as well use our Solar SOS tool for more or for further information on these state codes. Good. So how do I get to which settings? Yes, looking at the menu, for example, you might be wondering how you could get access to, let's say, load management, for example, or let's say event log. Yeah, so this serves as a quick guide for you to help you in navigating to these respective settings. So taking the event log, for example, you could go to, or you have to go through the system button here. So once you click on it, it will take you to an array or a drop down of different settings. Then you can now go scroll down and then go to event log. And as we always do, we will be sending you a copy of this presentation so that you can have this for your viewing later on at your convenience. Good. So in the case where you want to add a component, let's say smart meter, for example, what you'll need to do is to go to device configuration as shown earlier, and then go to components. From there, you will now have the ability or have access to where you can now add components. So in this case, we are adding a power meter or a smart meter, as the case may be. And then if the smart meter is going to be on the consumption path, you would now select consumption meter on the drop down. If it's going to be installed on the feeding point, you now select it respectively from the drop down. And once this is done, you can now click on add, and then you will be done with adding the respective component, in this case, a smart meter as an example. Good, so let's take a look at how servicing and component exchange normally works. So for the service process is usually a straightforward process. The tech support is contacted, but in most cases where we now have a new tool that you can use for quick troubleshooting, which is the Solar SOS online tool. You can now use that for quick diagnosis. And then, of course, you'd have to communicate the serial number. And after that is done, the error, the cause of the error is clarified. And then the exchange of the components is ordered. The exchange is accomplished. The defective component is thereabout returned, and then you now have a credit or a warranty payout. But this is made very, very easy by the use of or by using the services of our FSP Plus in our respective regions. So you don't need to go through all these processes. All you need to do is to contact them, and then they will sort the case out for you. But I must say here, of course, that these conditions could be maybe due to human error, manhandling, or maybe natural disaster, because our products are built very, very robust and rugged. So you would have, I can assure you that you would have less or very few occurrences of such. But in the case it happens, our systems are so modularized that the exchange is usually easy, because you can just take out the respective defective component and have it replaced in no time. Good. So we have, of course, helpful documents that can help you during commissioning, and of course during installation, as the case may be. We have a quick start guide that will help you to understand how the inverter is oriented. And as you can see in this case, this is an example using a snap inverter, as you can see. So you have an exploded view, and it gives you a good knowledge of how the inverter is oriented. And then in case you have any service case, you can easily make use of this exploded view. The quick start guide is usually delivered with the inverter, but the operating instructions, you can of course download that online. And then for same as the service instruction, and then online exchange component catalog, you can get them on spareparts.fronius.com. Good. So let's take a look at the spare parts we're talking about that can go defective. We have the power stack. This is how it looks like. And just like my colleague Mohammed explained, so this constitutes the circuit boards and then the power electronics components. Then we have the data communication gateway, which we preferably call the pilot, with its respective communication terminals and antenna. And then we have the control board. We also have the fuse board, the fans, and all other parts like the closure and the covers, as we can see. Good. So now let's talk about license management. So in the case where you have a defective component, you would have to replace it. And in replacing it, these components tend to come with with unique IDs or unique serial numbers. So it will have to be reintegrated into the rest of into the inverter. It will have to be reintegrated into the inverter. So to do so, you will have to, well, after replacing, you will have to get it connected to the internet via your monitoring device. And then once this is done, it is now automatically configured via a solar web And then, of course, there will be reconfiguration and alignment of your defective components onto the rest of the inverter system. Good. So in terms of license exchange, when is the license exchange actually necessary? It is necessary, like I said earlier, during control board exchange, pilot exchange. The pilot, of course, registers what type of exchange has been initiated and then guides the user through the exchange process, which is usually straightforward. So in this case, two license exchange processes are possible. We have online and then we have offline. Online, usually straightforward. The user only has to bring the device online. So once this is done, it automatically recognizes it, and the exchange of the license and alignment, of course, will be handled automatically. In terms of the offline exchange, the user would have to download the service file and then upload it manually when connected to the system. Good. Warranty option stays the same. You have 2 years warranty on delivery, and then of course this can be extended once your product is registered on SOLAR. Of course, we have options of 3 years additional 3 years for product warranty for materials, service, and transportation, which is usually the case for sub-Saharan Africa. And of course, we also have an additional another option of 5 years warranty. But in this case, it's just the material warranty. But like I said earlier, the first option is usually the case for sub-Saharan Africa. But mind you, you can of course have up to 15 years warranty in total. Good. So for local software updates, that's we're talking about updates this time around, we can do it. You have to download it and then drag and drop on the dashboard, as can be seen. And this, of course, can only be done by the technician, or you can have it done via SolarWeb. So in this case, you don't need any appointment or a visit to the site. That's not necessary. All you have to do is to gain access to the Fronius SolarWeb. Go to settings, go to components. Once you're in components, if there is a new update, you would have it indicated here. You have the one installed. In this case, it's version 1.9, and then you have the new version, which is 1.11, as can be seen. So once you have a new update, it will be indicated, and then you can now click on the update button, as can be seen here, and then your updates will automatically run. So talking about references, we have this wonderful reference that was installed in Castoria, Greece. It's a 1 megawatt peak project with a mixture of 13 Fronius Tauro Echo and Tauro Echo 50 and 100 devices working wonderfully. And we have another on Fronius site in Pattenbach. We decided to put this to show you live installation of both horizontal and vertical installations, as you can see, and as earlier said, projected by my colleagues in the previous slide. So these are vertical connections and these are horizontal. These are roof mount connections, as you can see. So for further information, you can of course go to our homepage, where you can easily have access to all our operating and installation instructions on www.fronius.com, and then go to the downloads. There you're going to get all the information you need. Or you can also visit our YouTube channel, and specifically speaking, you can actually have access to all our webinars, all the recordings of our webinars, and by using this link right here that you can see here. So this will take you directly to our Sub-Saharan webinar playlist. There you're going to have access to a compendium of all the webinar recordings that we've had. So if you need any information regarding any topic that we have treated, you can of course just visit with this link, and then you can have access to it. So that has been the presentation for today. We hope you got all the information that you were looking for. And in case you still have more inquiries, you can of course visit or dial the numbers on your screen, but more specifically speaking, you can of course contact your respective technical sales advisor for your respective region. Mohammed Sidat for Southern Africa,